Hello again. In this follow-up video, we're going to touch on the second type, which is combinations of tangent and secant for integration. If you haven't watched my part 1 video, we talk about combinations of sines and cosines, so make sure you watch that too if you need to. So let's get started. Alright, so just like we did for the type 1, we're going to divide this into cases. Case 1, where n is even. In other words, when secant has an even power, what do we do? Well, our goal again at the end is to use u sub. However, what we have to do is to take two of those tangents separately, because we need to use u equals tangent, and then the du is going to be secant squared. Okay, so that is why we need a secant squared on the outside. This is going to be our du, guys. Okay, so that's why we see here a secant with two of them less. Okay, in tangent we leave it untouched, and the next step, if once again the secant is raised at an even power that's higher than 2, like 4, 6, 8, then rewrite it as such that we can apply an identity, and this one is basically secant equals 1 plus tangent squared. We substitute that in. Now this seems like a even more complicated integral to solve, but it's actually easier, much easier, because we can say that u equals tangent x, so du is going to be secant squared x dx. Okay, this is du, and this is u times 1 plus u squared to whatever even power we have over here. Okay, that's basically case 1. Case 2. Case 2 is focusing on tangent, and tangent is being raised by an uneven power. Okay, what do we do whenever our tangent has an uneven power? We play with the secant. That's interesting, right? And the reason why we do that is because we want to pick our u as secant. So if you can notice a pattern here, for when we focus on secant, we pick u to be tangent, and when we focus on tangent, we pick our u to be secant. Okay, that's the pattern for these types of integrals. So if we say that u is secant, du is going to be tangent times secant, right? So therefore, it makes sense for us to remove one of the tangents and also one of the secants and put them outside. Okay, so that's what happened both here and here. One of the secants was moved to the outside. Same thing with the tangent. And again with the tangent, if it's raised to a power that's higher than 2, like 4, 6, 8, put that on the outside and leave it as tangent squared, so that we can apply an identity. And this is, there's actually a mistake here. It's supposed to say secant squared minus 1 raised to the r. Alright, using the same identity we used for case 1. And using the u sub, we write that in a different color. All of this is going to simplify to du, and then this is going to be u2 minus 1 times u to whatever power is being raised to. Okay, and for every other case, we just either apply either case 1 or case 2, and that's always going to depend up to you. Sometimes if you can pick case 1 and it may be very hard, so you may have to switch to case 2, and vice versa. That's just going to be a matter of practice and experience. Okay, this is going to be our first example. We can see the tangent is uneven and that secant is even. That means that we can use either case 1 strategy or case 2 strategy. Which one do we pick? Well, I'm going to pick tangent raised to the third power to work on. We can say that since tangent is raised to an uneven power, we can use, between us, what we called case 1, we can use, I'm just going to write it over here, u equals secant x, okay? And the u is tangent x secant x dx. What did we do for this particular case? Well, we need one of those tangents outside as well as one of the secants, correct? So we can rewrite this as tangent squared x times secant x. One of the tangents to the outside, one of the secants to the outside, dx. And again, if we look at this, this is our du. And we need to first do some do a conversion here. Almost forgot that. We apply the identity secant squared x minus 1 times secant times tangent times secant dx. And now we apply u sub du is u squared, and this is u. Therefore, we have u squared minus 1 times u du. It's just u to the third minus u du, which gives you u to the fourth over 4 minus u squared over 2. Remember to go back to the x world. And you can just leave it like that, and don't forget the plus c. And we're done. This is a great example because it doesn't quite fit the mold. It's not either case 1 or case 2. And this is an example of, just like in the previous video where we just had a cosine and no sines being multiplied, we did use some similar techniques and approaches in order to solve it. I'm not going to use the same sort of thing here. What I'm going to do is I'm going to rewrite it and split it into tangent squares, because I know that there's an identity that I have on my list for tangent squared. Okay, and I can either substitute one of them or both. It makes more sense if I just substitute one, because if I substitute both, I can see that I'll get like a secant to the fourth power plus something. It just makes things more complicated. Let's just keep it this way. So we distribute, we get tangent squared times secant squared minus tangent squared x dx. The way I'm going to solve this is I'm going to split it into two integrals. It's going to be my first one, and it's going to be my other one. Let's work on the first one first. Integral of tangent squared times secant squared. That may look hard at first, but it's actually very easy. The derivative of tangent, if I say u equals tangent secant squared, right? It's basically all of this. This can be a du, and this can be a u squared. And that's exactly what we're going to do. It's so easy. This is u to the third over 3. We go back to the x world. And we're done with that one. So now let's focus on the other one. The integral of tangent squared. The way I'll solve this is by applying trig identity again. Secant squared x minus 1 dx. Because it's going to be much easier, because the integral of secant squared is simply tangent x. I can integrate directly, and that's why I did it that way. Okay, so we're done. It's just a matter of adding both parts. So tangent to the fourth power x dx is 1/3 tangent cubed x minus tangent x plus C, and we're done. Remember, plus C, it's not going to be a minus C in this case, because plus C, it's like a placeholder, a general term part of the expression. Okay, so we're done. Let's look at one final example. And this one is also interesting because secant is raised to the first power. So it's going to be it's going to feel kind of tricky at first. How do I work on this? Instead of splitting the tangent, which wouldn't make any sense, I'm going to use an identity, okay? That's what makes most sense in this case. So secant squared minus 1 times secant. The most logical thing to do next would be to expand. Secant cubed minus secant. And this may seem hard, but again, it's easy. So this one is one of the basic integrals. It's in your table, and it should be in your memory. So this, we already know it's natural log absolute value of tangent x plus secant x, right? What about this one? I already have a video on that specific integral. I'll link that video in the description so that you see how I obtained results. I'll just give it to you in this for the purposes of time saving. You can go ahead and watch my other video and learn a little bit more about that one. For that one, instead of using, I'm sorry, this is secant cubed. Instead of using, what I'm going to say is instead of using like trigonometric tricks and like, for instance, like separating it to secant squared times secant and then turning it into like tangent squared plus 1 times secant. Well, that's not going to work here because secant is raised to the first power. This is just making things even more complicated. So what we did for this particular integral, and this is the easiest way, the easiest method that you can use for this particular integral, is to use integration by parts. So I want you to go watch, if you haven't seen it, my integration by parts video. But that gives you, in the end, 1/2 secant times tangent plus 1/2 natural log absolute value tangent x plus secant x. Therefore, the final result is going to be the first part, which is this one. So 1/2 secant x tangent x, and then I'll have 1/2 of all of this. Let me just highlight it. All of this minus this. So it's basically 1/2 minus 1. That leaves us with minus 1/2 natural log absolute value tangent x plus secant x and all that good stuff, plus c. And we're done. So hopefully this video helped you guys with trigonometric integration. If you have any questions, leave it in the comments. And thank you for watching. This is the Electric Tutor signing out. I'll see you later.